Hello, my name is Adrian Stevens. In a previous video we looked at the microphones that I have available to record with, and in this video we'll look at the sound quality and the noise that the microphones introduce. So I'll record them. I won't show them all being recorded because that will be a little bit tedious, but I'll show you some of them being recorded. The first microphone that I have available to me is the Yeti. Let's monitor this. Transport. Testing. So click to start monitoring. Okay, we're at the -12 to -6 levels, so that should be okay. Testing. 1, 2, 3, 4. I'm going to leave a silent period so that we can analyze the noise. Okay, next microphone will be the no-name condenser microphone. I've just plugged it into USB. I have to tell Audacity to rescan audio devices for it to see it, and it will now show it as C Media USB. The reason I call it no name is the manufacturer's name doesn't appear on the microphone description, just the name of the manufacturer of the electronics in it, which is C Media. So select that device, hit monitor, testing. It's volume's up max. We're not quite getting to the level. If I bring it really close I can, but I would want to keep it about here, otherwise I'm going to get popping. So let's mute the track we've already done and record from the start. Testing. 1, 2, 3, 4. Okay, we've done that. We'll mute that track. What should we do next? Let's try the boundary. Test. You see, this is not very sensitive. The volume is up max. If I move this down to the table where it's supposed to be, nothing magical happens. It just gets quieter. So let's record. The next microphone is the USB lavalier. Transport rescan, and this will show it as an AK5371. Testing. 1, 2, 3, 4. Now I'm going to record from what I called the rat's nest lavalier because it's got a long cable, and I'm connected via a USB to dongle here, USB to audio dongle, because I don't have a microphone socket in my laptop. As you see, it's very quiet. Let's turn volume up. That's probably about okay. Good. The next to record on is the smartphone. I have an Android smartphone and I have an app installed on it called Easy Recorder. Easy Voice Recorder. So let's do a recording. Testing. 1, 2, 3, 4. And the reason that I use this app is that I can... Testing. 1, 2, 3, 4. I can email this to myself. So we'll pick up the email and import that into Audacity in a moment. Okay, the final microphone to test is the laptop microphone. You remember I pointed out 2 little pinholes at the top of the laptop screen. Well, we've switched to microphone array, Realtek high something or other. The volume level is set to maximum, and testing, you can see we're not reaching the -12 at the distance of about 18 inches. If I move closer to it, you can, but that's not exactly a very dignified position to adopt when recording. So let's record using this. Okay, so we've now got all of the recordings from the various different devices. They're all muted, and we'll listen to them one at a time and comment on the quality of the sound and analyse the noise. So we'll unmute the track and play the speech. Testing, testing, 1, 2, 3, 4. Okay, sounded fine. We'll use the waveform dB display mode. Okay, so we just changed to waveform dB mode, and you can see this shows the noise a bit more. Now, there's not a lot of point in me playing anything at that level because there's the same amount of noise coming in through this microphone here that I'm recording the voice over. But if we normalize that and play it, we're hearing what's going on, and the noise is actually primarily environmental noise. There's the rumble of the machinery in the field behind me, where they're building a new village hall. Let's listen to that again. Yep, that's mainly the rumble of traffic and the machinery outside. Okay, so I'm going to solo each of these tracks as we listen to it. Also, I'll select the track and do replay gain. Okay, so let's have a look at the no-name microphone. We'll change the display mode to waveform dB, and immediately we see that this microphone has actually got a DC offset. Well, let's listen to it first. Testing, testing, 1, 2, 3, 4. Sounds quite good. I can hear the hiss in the background. It sounds quite bassy. Let's do the normalize, which will remove the zero offset, or the DC offset. And let's listen to that. We're picking up the the rumble from the machinery, but there's also more hiss in this than with the Yeti. And that hiss is coming from the microphone electronics. Let's go to the next microphone, the Yoda, switch to waveform dB mode, and again we can see there's a DC offset, but this time the other way. Let's apply replay gain. So let's listen to the speech. Testing, testing, 1, 2, 3, 4. That's quite a nice sound. I'm quite happy with that. Let's listen to what the noise sounds like. Again, very similar to the previous one, which is not surprising because I think they must have the same electronics. Let's go to the USB lavalier, switch to waveform dB mode. Testing, testing, 1, 2, 3, 4. Well, a lot less bass, I think, than the previous one, and that's probably because it's a much smaller device. It's completely different technology. It's a not a condenser, it's an electret microphone. Let's play that. Not so much hiss. I can hear the rumble from the machinery, and I can hear a high-pitched whine in that. Now we can dive into this in a bit more depth, so we can use analyze, plot spectrum, and this will tell us what it finds. And normally in noise you'd expect to see some kind of smooth curve, but we're actually seeing a spike here at 1020 Hertz. Okay, so we've listened to that. Let's look at the analog lavalier, switch to waveform dB. And this has again got a DC offset. Testing, testing, 1, 2, 3, 4. Well, that's okay. I can hear the hiss in the background, but no problem with that. Good quality. Let's normalize this. and listen to the noise. Well, we're hearing the rumble, so all the microphones so far are picking up the rumble, but there was a lot more hiss in this. Okay, let's go to the laptop. This is very quiet, so we're going to have to switch to waveform dB first, and effect replay gain. Okay, that's increased it quite a lot. Let's listen to that. Testing, testing, 1, 2, 3, 4. Now that's very interesting. Let's listen to that again. Testing, testing, 1, 2, 3, 4. That sounds quite weird to me. It doesn't sound like any of the others. And that's showing the effect of processing within the laptop. If we look at the noise is actually at quite a low level. If I play this without normalizing it, you can hear it, but it's not objectionable. If we normalize this and play that, now what we're hearing is the high-pitched parts of the machinery outside. We're hearing a lot of hiss, but we're not hearing the rumble at all. So the laptop microphones seem to be completely insensitive to low frequencies, but they've also done... Testing, testing, 1, 2, 3, 4. They've done processing on what they're listening to in order to try and reduce the noise level. I don't particularly like this. Testing, testing, 1, 2, 3, 4. It's almost like there's an echo, but in this room where we are, it's not echoey because I'm hung with blankets. So I don't like that. I wouldn't be happy recording using that. Okay, the last one is the phone. Okay, let's listen to this. Testing, testing, 1, 2, 3, 4. Now, in my mind, that sounds quite good. It's not sounding over-processed. The level of the noise is not offensive either. Testing, testing, 1, 2, 3, 4. Actually, I think I can hear a little bit of processing there. Let's listen to the noise it picked up. Quite a lot of the rumble it's picked up and a lot of hiss. So it's a mixture of environmental and electrical noise that we're hearing there. But I'd say it's done a pretty good job. I mean, this is a low level of noise we're seeing compared with the laptop speaker. And the laptop speaker has done a lot of noise reduction. But the difference, of course, was I was recording this at a couple of inches. If I was to record in the laptop at a couple of inches, you'd see something a lot better than we saw here. Okay, so we've listened to the signal and noise qualities of all of the different microphones. In the next video, we're going to look at noise reduction and see if we can actually remove most of the noise from the recorded signal without damaging the signal quality. Well, thank you for watching and goodbye.